In the previous video, we discussed some characteristics of friction. In this fifth lecture video on force, we will discuss how to calculate a frictional force. First, let's take a look at the formula for friction. F sub F, or the frictional force, is equal to the Greek letter mu multiplied by F sub N, or the normal force. Mu is the coefficient of friction. The coefficient of friction is just a ratio between the frictional force and the normal force of an object. The coefficient of friction is a constant for two surfaces in contact with one another. We will look at some values for the coefficient of friction in a minute. First, in order to understand the normal force and the frictional force, it may be helpful to look at a force diagram. We can see that the frictional force acts in the opposite direction of any pushing force where motion is directed. For our purposes, we will assume only constant motion with no acceleration. Therefore, we can say that the pushing force will have the same magnitude but the opposite direction as the frictional force. The weight force acts in the opposite direction as the normal force. We will discuss more about the normal force later. For now, we can assume that all of our problems are on a level surface, so the weight force has the same magnitude but opposite direction as the normal force. Therefore, in our calculations, we can use the magnitude of the weight force as our normal force. This table provides some common values for the coefficient of friction mu. Notice how there is one column for static or starting friction and another column for kinetic friction. The static friction coefficients are also larger than the kinetic friction coefficients. The only exception to this rule is if there is lubrication present, like the lubricated steel on steel. Let's take a look at an example calculation involving friction. A snowmobile weighs 2,220 newtons. What force is needed to start pushing the snowmobile across the floor if the coefficient of static friction is 0.57? First, we will write down all of the data we are given. The weight force has the same magnitude but the opposite direction as the normal force, so we can say that the normal force is equal to 2,220 newtons. The coefficient of static friction, or mu, is 0.57. We are trying to find the pushing force. If we are assuming constant motion with no acceleration, we can say that the frictional force is the same thing as the pushing force. The basic equation to solve for frictional force is that the frictional force equals mu multiplied by the normal force. Substituting, we can see that the frictional force is equal to 0.57 times 2,220 newtons. This gives us a value of 1,270 newtons as the frictional force, which is the same as the pushing force. This concludes our discussion on friction.